All right, this is the key to your review. I think I have really fixed my mic issues for real now. So hopefully this will sound okay to you. All right, so we're going to change the degrees to radians and the radians to degrees. So when you do this, there is a conversion factor that you can use. If you can figure out the reference angle, and it's one that you should know from the unit circle, then you can use your unit circle knowledge to help you, but it's not going to help you on all of them. So this 310 degrees, the reference angle would be 50, because that would be the acute angle that would get me back to the x-axis. And 50 is not one of my special angles, so it doesn't help. So I just need to go ahead and multiply. So 310 times pi over 180. And then I can divide them both by 10, so I can cancel out the zeros. 31 is a prime number, so I really can't do anything else. So it's 31 pi over 18. All right, so then number 2, I got a negative 155. That reference angle is 25. That's not going to help me either. So I need to multiply negative 155 times pi over 180. Can't divide them by 10, I can't divide them by 2 or 3, but I can divide them by 5. So if I divide this by 5, 5 goes into 15 3 times, 5 goes into 5 once, and then when I divide this, 5 goes into 18 3 times with 3 left over, so that gives me 36. 31, still a prime number, so it's negative 31 pi over 36. All right, so then when I'm going from radians to degrees, this one looks like one I should know. The reference angle here is pi thirds. So think about what's happening on my unit circle here. I know that my reference angle is pi thirds, which means my reference angle in degrees is 60. That should be a pretty easy thing for you to reason through. So if I'm here, I go 7 pi thirds. So this is 3 pi thirds because it's pi. This would be 6 pi thirds, so I got to go one more in here, and there's where my 7 pi thirds would be. So in thinking in terms of degrees, that's going to give me 360 plus another 60. So 360 plus 60 gets me 420 degrees. This negative 4 pi ninths, well, pi ninths or any of the ninths, it's not one of my special angles. So I can just convert. And I'm going to multiply negative 4 pi ninths times 180 over pi. So the pi's are going to cancel out. 9 goes into 9 once, goes into 180 20 times. So negative 4 times 20 is negative 80. Oh, no pi. Negative 80 degrees. All right, so then I have to state the quadrant in which the terminal side lies, then give two coterminal angles, one positive and one negative. Okay, so I have negative 285 degrees. Here is this. So I'm going to go negative 180. This is negative 270, so a little farther. Negative 285 gets me in the first quadrant. So to find my coterminal angles, I would either add or subtract multiples of 360. So I can take this negative 285 and I will add 360. That gets me 75 degrees. So there's my positive one. And then negative 285 minus 360 would get me negative 645. And there's my negative coterminal angle. And there are an infinite number of answers. Those are the easiest ones to get to. All right, so negative 3 pi fifths. Here I'm at 0. This would give me 5 pi fifths. Halfway in between would be like 2.5 pi fifths. So since I went 3, I'm here in the third quadrant. Then I'm going to take this negative 3 pi fifths, and I'm going to add 2 pi to it, but I've got to do 2 pi in disguise because I'm talking in fifths. So 2 pi's is 10 pi, or 2 pi is 10 pi fifths. So this would give me 7 pi fifths for my positive angle. And then my negative 3 pi fifths, I subtract 2 pi in disguise as negative 10 pi fifths. then that's going to give me negative 13 pi fifths. There you go. Okay, so now we're going to find the length of the intercepted arc, round and round to the nearest tenth, but we are absolutely not doing that. Okay, so to find the arc length is r theta. You know, the radius is 8.5, but we would use that as 17 over 2, and then our theta is in radians, so that's good. So I'm going to get 17 over 2 times 5 pi over 6. And I can try and reduce. 17 and 5 are both prime numbers, and neither one of them will divide into those. So I just need to multiply my 5 times my 17, so that'd be like 50 plus 35, which will give me 85 pi. Oh, that's just an 8. 85 pi over 12, and that's feet. All right, so number 12. Okay, I just got interrupted. I have no idea what the last thing I said is, so we're on number 12. This 120 degrees, we need to have that in radians, and we can do that a couple different ways. You can straight up convert, but 120 is an angle that we should know, and either you just know what 120 is in radians, or you can use the reference angle. Reference angle is 60. 60 is pi thirds. 2 times 60 is 120, so that would make this 2 pi thirds. And the radius is in the form it needs to be in, so I'm good. So arc length is equal to r theta. So that's equal to 6 times 2 pi over 3. Then I can reduce. 3 goes into 3 once, goes into 6 twice. So that just gives me 4 pi inches. All right. 24. I have a point to negative 11, point with the terminal side of theta in standard form. I want to find the exact values of the trigonometric functions of theta. So I'm going to draw myself a little picture here. So 2, negative 11 would be like here. So my triangle looks something like this. This is my theta. And so this is 2. And this is negative 11. So I need to find the radius. So you can do 2 squared plus negative 11 squared equals x squared. So it's going to be 4 plus 121 equals x squared. So x squared equals 125. X equals the square root of 125, which equals 5 square root of 5. So that is my radius here, 5 square root of 5. So what I have here then is that when I want sine of theta, here's theta, opposite over hypotenuse, so it's going to be negative 11 over 5 square root of 5. So I have to rationalize, and I'll get negative 11 square root of 5 over 25, because the square root of 5 times the square root of 5 is 5. 5 times 5 is 25. This is my sine theta. Cosine is adjacent over hypotenuse, so that's 2 over 5 square root of 5. When I rationalize, that's going to give me 2 square root of 5 over 25. My tangent is going to be opposite over adjacent, which is negative 11 over 2. Then my cosecant is the reciprocal of sine. So if I just take the reciprocal here, I'll have negative 5 square root of 5 over 11. Secant is going to be 5 square root of 5 over 2. And then cotangent is going to be negative 2 over 11. Now on 25, this is negative 6/7. I don't know what happened to my fraction bar there. So it says if cosine is negative 6/7 and sine is less than 0, well, all students take calculus, right? So if cosine is negative in these two quadrants. And then Sine has to be less than 0, so it's also negative. That's in the third quadrant. So here is where this angle is going to live. Looks like this. Okay. This gives me this is adjacent over hypotenuse. This is my theta. So it's negative 6 over 7. So then I have to find my y value here. So this will be negative 6 squared plus, that would be my y squared. I used x up there. That's not really my x value. I just used x as a variable. Might have been a bad idea. I probably should have used r. Equals 7 squared. So I'm going to get 36 plus y squared equals 49. So y squared equals 13. Y equals the square root of 13. Okay, but it's really over here negative square root of 13. So my sine theta, sine is opposite over hypotenuse, so that's negative square root of 13 over 7. Cosine is adjacent over hypotenuse. Of course, we already had that anyway, negative 6 over 7. Tangent is opposite over adjacent, so negative square root of 13 over negative 6, which is the square root of 13 over 6. All right, so then cosecant is a reciprocal of sine, so this would be negative 7 over the square root of 13. So that's negative 7 square root of 13 over 13. Then this would be negative 7 over 6. And here I would get 6 over the square root of 13. So this is 6 square root of 13 over 13. All right, on the back. I want to find the area of each sector, and again, I am not rounding to the nearest tenth. All right, so I didn't change these numbers to make them nicer like I did on the assignment, but I will on the test. So we'll make it through these really yucky numbers on number 13, and then we'll be fine moving forward. So this 4.1 can be changed to 4 1/10. So 4 1/10, and then that is going to be 4 times 10 is 40, plus 1 will be 41 over 10. Okay, which should make sense for that too. Just sometimes they reduce, but we've got 41 over 10. To find the area here, area is equal to 1/2 theta r squared. So this is 1/2. My theta is 2 pi over 3 times 41 squared. Oh, not 41 squared, 41 over 10 squared. (41 over 10, the whole thing squared). Okay, so the 2's, these will reduce out. 41, unfortunately, is a prime number, so it's not going to reduce with either one of these things. So what I have next then is pi thirds times, well, 41 squared is 1681 over 10 squared is 100. So nothing else is going to reduce, and in the end my area is 1681 pi over 300 miles squared. You're capable of squaring those big numbers. That's not one I would expect you to know, but you're capable of actually doing the computation. I wouldn't necessarily expect that. I'll make sure they're at least a little bit prettier for the test. All right, number 14. So I have 300 degrees. I need that in radians, right? So instead of 300, my reference angle for 300 is 60, right? And you can't see that in yellow. My reference angle is 60, which is pi thirds. So what I need, this 4th quadrant, my 4th quadrant pi thirds angle would be, so you can think of it this way if you don't know, to go all the way around, this is 3 pi 6 pi thirds, because it's 2 pi. 6 pi thirds, but I didn't get all the way there, so this is actually 5 pi thirds in radians. Okay. So then when I go and substitute all of this in, my area is going to be equal to 1/2 theta, which is 5 pi thirds, times 14 squared. So then this gives me, I can't reduce the 2 and the 14 right there. I could split it up and reduce like we did the other day, but I know what 14 squared is, and so that might be better. Might be better for me to go ahead and square 14 than it would be for me to make it 7 times 14. So I'm going to leave it for right now and make this 5 pi over 2 times 3 times 196 over 1. Then I can reduce this. I can reduce the 2 and the 196, so give me 98. And then the only thing I have left there is a 3, and 98 is not divisible by 3. So I can do 5 times 100 and subtract 10. So 5 times 100 is 500. I subtract 10 from that, and I get 490. So my area is going to be 490 pi over 3 centimeters squared. All right, so linear and angular velocity. An 18-inch bicycle tire is making 140 revolutions per minute. Find the linear speed in miles per hour. So my linear speed, in order to find that, I have to have my arc length. Okay, so my arc length is r times theta. Since it's an 18-inch tire, the radius is 9. Theta is 2 times pi times the number of revolutions, which is 140. So give me 18 pi times 140. Now, I'll just leave it like that for right now because I'm not done, and that'll help me reduce some stuff. So I have that arc length in inches. So then my velocity is that arc length, which is 18 pi times 140 inches over 1, and that's revolutions per minute, so it'd be in 1 minute. No, I'm not done because it didn't ask me for inches per minute, it asked me for miles per hour, so I have to do some converting. So here we go. I want my inches to reduce out, so I'll make those into feet. 12 inches, 1 foot. Then I've got to cancel my feet out so I can get miles. 5,280 feet in 1 mile. So I've got my miles. And I don't want minutes, I want hours. So the minutes get canceled out and hours down here. So I get 60 minutes and 1 hour. So here's where I am. I've got my miles per hour, and I'm going to start reducing some stuff. All right, so let's see if I can get this 18 and this 140. I don't like 140 as much as I like 60, so divide these 10s out, get rid of that. 528, half of that is 264, and that gives me 7. 7 does not divide evenly into 264. I don't think I'm going to get my 7 out of there, but now that I look at this, 12 does divide evenly into 6, so I can make that into 5, make that into 1. This 264, I can divide it by 2 and get 132. And divide this by 2 and get 9. So then that 132 is divisible by 3. So I can make that into 44. This into 3. So let's see what I have left here. I have left this 3, this 7. Don't forget about pi. 1, 1, 1. I have this 44 I need in the denominator and this 5 in the numerator. So let me rewrite all that then. So I've got 3 times 7 times 5 pi over 44. Well, 44 is divisible by 2, 4, and 11, none of which I have in the numerator, so I think I'm stuck as far as reducing is concerned. And I can do 7 times 5, which is 35. 3 times 35 is 105, so that's going to give me 105 pi miles. Oops, sorry. 105 pi over 44 miles per hour. There's my answer. Okay. Be very methodical in your reducing. Make sure you can read your own work. Rewrite it if you need to, way before I did, if you're going to get lost in all those markouts that you have up there. All right, so then we want to find the angular speed, or my angular velocity, if the bicycle tire in radians per minute. So angular speed is omega equals theta over t, right? So your theta is 2 pi times the revolutions, which were 140. And that's in radians and per minute. So the revolutions per minute, so this is 1 minute down here. So I am in radians per minute, so that's good. So this is going to give me 280 pi radians per minute. All right, number 17. Find the linear speed in meters per second. We have a CD with a radius of 6 centimeters, rotates at a speed of 237 revolutions per minute. So arc length is going to be r, which is 6, times 2 pi, times the revolutions, which are 237. So I think I will just do 6 times 2, and I'll leave that as 12 pi times 237 centimeters for the moment. And that's my S, so my velocity then is going to be that 12 pi times 237 centimeters for every 1, and that was revolutions per minute, so it's every 1 minute. But that's not where I'm going to end because it asked me in meters per second, right? So I have centimeters, C meaning 100, so there's 100 centimeters in every meter. Go from centimeters to meters. It's 100 centimeters for every 1 meter. And then minutes to seconds, so I'm going to have minutes in the numerator so they cancel out. Seconds down here. So I have 60 seconds for every 1 minute. Right. And so I'm in my meters per second there. All right, so when I try and simplify this, 12 goes into 60 5 times. That's nice. All right, so 237, not divisible by 5, not divisible by 2, and really in that 100, that's what we have is 10s and 5s and 2s, so I can't reduce any more at all, and I end up with my velocity being 237 pi over 5 times 100 is 500, and then this is meters per second. Okay. Then find the angular speed in radians per minute. So this is my omega is equal to theta over t. So that theta is 2 pi times 237 over 1. So this is minute. And this would be radians. And it's asking me for radians per minute, so that's nice because I'm not going to have to convert. All I have to do here is multiply 2 times 237. So 2 times 200 is 400, 2 times 30 is 60, and 2 times 7 is 14. So that's going to give me 400, omega is going to equal 474 pi radians per minute. All right, so I'm supposed to find the reference angle for each of the following. So your reference angles are what gets you back to the x-axis. So basically, if I'm in the second or third quadrant, I'm either adding or subtracting from 180, and then from 0 and 2 pi if I'm in quadrants 1 and 2. So this 164 is over here in quadrant 2. So my reference angle is going to get me to 180. So to figure that out, this is just 180 minus 164. And then that tells me that I have 16 degrees left to go to get to 180. This negative 461, right? So if I go, this is negative, so I'm going around this. This is negative 360. So then I'd have to go a negative 101 over to here. Okay, so I'm in this quadrant right here. My reference angle is going to get me back to this 180 right here. So if I forget the 360, yes, I went all the way around 360, but I went another 101 degrees. Since I went another negative 101 degrees, I got to know how much farther I'm going to go to get to 180. So if I just add 180 to negative 101, that's going to give me 79 degrees. All right, negative 3 pi fourths. The radians make it a whole heck of a lot easier. So here, remember, this is 0. This is negative pi halves, which would be negative 2 pi fourths. This would be negative 3 pi fourths. This is negative 4 pi fourths. So I only have pi fourths left to go. Reference angles are always positive, always acute. 13 pi over 9. Well, this is 0. This would be 9 pi over 9, right? This would be 18 pi over 9. Halfway in between that would be like 13.5 over 9, pi over 9. So I've got this right here. We're at 13 pi over 9. So I didn't make it all the way here, right? So I'm not worried about 2 pi. I'm dealing with 180, which is pi, basically. And I got to know how much more I went, how much farther than pi I went. So if I do 13 pi over 9, and I subtract pi, which is 9 pi over 9, that means this distance that I went here is your 4 pi over 9. So your reference angle is 4 pi over 9. All right, so then on 30 through 33, it's asking me for, sorry, I'm trying to make this cooperate here. It's asking me for the exact values. And on 33, lost the fraction bar again. Here is where the hand trick can come in handy. Get it? All right, so here's the first quadrant. This is your pinky finger, your thumb. Then if you have your palm up, this is your index finger, middle finger, ring finger, right? And so this is 0, pi 6, pi fourths, pi thirds, pi halves. So sine of 4 pi thirds. You need to think about the reference angle. The reference angle for 4 pi thirds is pi thirds, which is your index finger. So if you pull that finger back, you have, this is cosine, this is sine, because xy is cosine sine. So you got 3 fingers. So what you're looking at here is square root of 3 over 2. But you have to decide, because this is not a first quadrant angle, but this value is going to be at least part of the answer. You have to decide which quadrant you're in and whether or not sine is positive or negative in that quadrant. Because remember, we have all students take calculus. So negative 4 pi thirds, right? I'm here. This is negative 3 pi thirds, so negative 4 pi thirds puts you in the second quadrant. Second quadrant, sine is positive, so my answer is square root of 3 over 2. All right, so secant of negative 7 pi sixths. You have to have your reference angle and know what that is. Reference angle for negative 7 pi sixths, or positive, is pi sixths. So that would be your ring finger if you have your palm up. Secant is 1 over sine. So the cosine of pi 6 would be the square root of 3 over 2. So cosine, I'm writing this down. You wouldn't necessarily have to write it down, but I don't want to lose you. Cosine of pi 6 equals the square root of 3 over 2. That is not my final answer because, first of all, I don't want that angle and I don't want cosine. I need to decide, first of all, if it's going to be positive or negative, like which quadrant am I in. So this negative 7 pi 6, I'm here, coming around. This is going to be negative 6 pi 6, so 7 pi 6, I'm in the second quadrant. Second quadrant, cosine is negative. Okay, so I'm going to have to make this negative. And I want the reciprocal to actually get me secant. So my answer then is going to be negative 2 over the square root of 3, but I have to rationalize, so it's negative 2 square root of 3 over 3. All right, cosine of 7 pi fourths. Reference angle is pi fourths. Your little hand trick here, pi fourths is your middle finger. So cosine is square root of 2 over 2, and so is sine. So I know I'm going to have square root of 2 over 2, but then I have to decide which quadrant I'm in. So if I'm here, this is 4 pi fourths. This will be 8 pi fourths. I don't quite make it, so I'm in the fourth quadrant at 7 pi fourths. In the fourth quadrant, cosine is positive, so this is just square root of 2 over 2. All right, so cotangent is 1 over tangent. The reference angle for pi sixths is pi sixths. And so pi sixths is your ring finger. So you know the ordered pair that you get there then is square root of 3 over 2, 1/2. This is your cosine, this is your sine. I want tangent because I really want cotangent. Well, tangent is sine over cosine. Cotangent is going to be cosine over sine. I have the cosine value, I have the sine value, I just have to make a fraction. So it's the square root of 3 over 2 over 1/2. That means I get square root of 3 over 2 times 2 over 1, which is just the square root of 3. And there you go.